We are live. So we'll just wait a little bit for everybody to come in and join us from around the world. Because I know people are just waiting to hear you talk about this, you. Because you are the master of this. I love that I get to help you, you know, with these comments and everything else that comes in. So I know this morning what we're going to talk about is planning and preparing for a successful turnaround and overhaul. And this is something that I think a lot of people they talk about turnarounds, they talk about planning for it, and they forget about the oil. Like that's the most important part. How could they forget about the oil, right? And then
Yes,
they get into the turnaround, they're like, oh my God, we did not plan for this. So that is something that I think that a lot of people overlook. They forget about the oil, but it's something that is so critical because that's the bloodstream. That's what we need all the time. So
yes,
even though you're planning, say, yes, we're changing out that turbine and we're doing this and we're doing that, um, you need to think about the oil. You definitely need to think about the oil. And it's something that we could plan in advance. And I know you're gonna carry us through all of the different steps, what you need to look for, what you don't need to look for. Um, and I know things in terms of a turnaround where you think about, okay, well, is it that I have to change the oil? Is that an option for me? Because everybody's system is so different. So I am very glad that we get to talk about this topic, that we get to help a lot of people who are, I want to say, excited as I am about the topic, but maybe they're not that excited. But I know that it's something that a lot of people they forget, they don't think about it, and it's something that we all need to plan for, especially going into these turnarounds. Because if you're sorting out your equipment, you should sort out your oil as well. Like, why not, right? So I'm going to turn it over to you, and I know you have this completely done. So you're going to take it away from here. And everybody's excited about it. I am excited about it. So I'm going to leave it to the master. And it's all yours now.
thank you so much, Sanya, for the
Welcome.
wonderful introduction and your very good words and correct words. It's entirely this what we will try to cover, and thank you for coordinating this. So, welcome everybody on this session, Fluitech session. My name is Yo Ameye, working for Fluitech. And as you can hear, I have a European accent, living in Belgium. And so today we will help you to talk about and planning and preparing for successful turnaround and overhaul. So I have a small introduction, 2 slides, and I like to look at what's available on the media and social media. And if you look on the Wikipedia, I found the definition quite well. So it's a scheduled event, a turnaround for process units, industrial plants, and important. It needs a lot of coordination. It's important. Remember that there's always a team, a TAR team behind it, coordinating the downtime. Other names often given to turnarounds are shutdowns, outages. Um, I also loved how Wikipedia is mentioning that turnarounds are, and I would say can be expensive, can even be more expensive because, of course, there's a lot of production. The unit is offline. There's also direct cost of labor, tools, heavy equipment, and like I said, it's very mostly scheduled. There's a budget, um, and I come back to the fact that turnarounds can be expensive, but can even be more expensive because if there's delay in a turnaround or additional damage occurred. So the fact that this is so important for the plant, it needs to be prepared very well. In the whole consensus of achieving a successful turnaround, the preparation is 90% of the success. Today, like just Tanya was saying, we will attach a lot of attention to the oil, the condition of the oil in advance of the revision or the outage. To protect the asset and also its functionality. In addition, there's also consultation. There's a team of people in this star for mechanical people, maintenance, operational, people from outside the company, oil suppliers. So there's a team, and it's important that it matches, like the puzzle, the jigsaw, putting all the pieces together. And then last but not least, it's effectively doing the actions. What are you going to do to assure that you meet the reliability, the productivity, and also the sustainability? And yes, we will come back on that aspect of sustainability. That is absolutely important today with turnarounds and revisions. In What we have tried here is to look at chronological possible sequence. Once again, this is not, I would say, defined, but it's based on the experiences we have. How would you, if you organize an overall, plan this? And that means it starts even longer than 6 months because you have to find budget, suppliers, and but once you're getting close to the overall 6 months in advance, it's important to understand what is the condition of my oil on my equipment. And that is very often forgotten because why is it 6 months in advance? Because then it gives you a lot of time to prepare actions, because out of that first oil analysis, a lot of information will come out, tell you what kind of cleaning you need to do. Do you need to look maybe at some varnish treatment? We will cover that. Maybe you need to add a solubility enhancer. And in these phases of I would say, before the overall the 6 months, that you can achieve a lot of information. Once again, at the time of the overall, then you will look at, will I change the oil? Or will I not change the oil? We will cover that also today in our session. What flushing oil will I use? Or maybe I don't need a flushing oil. And so these different actions, it's in team decided. And at Fluidtech, we have our products who will help you to make this decision easier and faster and even more efficient. Now, the preparation of a turnaround, before I speak about it in more detail, turnarounds and opening equipment is always containing a certain percentage of risk. If you open an equipment, if it is a simple hydraulic system or even a complex gas turbine, opening the system and the lubricating system, the turbine components, it contains always a risk factor. So if you can avoid that, of course, that will reduce the quantity of risk. Now, controlling that risk factor, it's important that you look first of all at the oil information, the oil condition information. It's the same with the human body. Before you will have a possible intervention, they will do a whole checkup of your body. It's the same here. Now, of course, oil analysis and oil analysis is two. There's different standards. Make sure that you apply the right used oil analysis standards. I will come back on that later, but make sure you look at the right ASTM standard, your OEMs. And also important, once you define the standards, that you select the right laboratory. And I mean a certified laboratory who has all the accreditations and in whom you have trust, and which will not only give you oil analysis, but also diagnostics. Flush or not flushing. That is the question very often asked. I will come back on that in much detail, but make sure you apply the right standards again for flushing. There are standards, for example, an ASTM standard. We'll talk about that. And last but not least, in the preparation, as part of the oil aspect, of course, there are other parts of mechanical components, but looking purely at the oil is, do I have to change the oil? That is a very important question. And there are possibilities to extend the lubricant lifetime, again, with a very low risk factor, looking at sustainable solutions and strategies. For everybody who's attending here in this session, I don't have to prove you the value of oil condition monitoring, but still today, oil condition monitoring, what can it help you? Of course, enhance equipment life and reliability, reduce equipment downtime, lower the maintenance cost. Well, think about a turnaround. These maintenance costs, they are can be quite high. That means that in condition monitoring, you need to look at the contamination. Do we have particle contamination? Do we have maybe varnish contamination? Oil health, how much of my antioxidants have depleted? And are these linked to the machine health? Maybe you have a problem with your cooler. Maybe there's too much water in the system and that the cooler may be leaking. Maybe the vent filter is not working properly. So all those actions are important. And like we say, it's clear that oil analysis, it's like a contribution on multiple levels to sustainability. It makes your energy or energy more sustainable. You can even look at more autonomous remote operation. And when we look at turnarounds, it reduces the equipment replacement, bearings, valves, gearboxes, and of course, it also, with a good, profound, in-depth oil analysis program, you can extend the component life. The last part I want to speak about oil analysis as preparation for tar. I want to take a helicopter view. Um, Oil analysis and condition monitoring have a lot of guidelines today. And as an ASTM member, I've been working quite heavily and being involved with the standard for or practice for in-service mineral, steam, and gas turbine lubricants. It's the ASTM D4378, or here in Europe very often use the VGB standard, VGB 416, giving you all the guidelines, what parameters you should look at, what are the condemning limits, what are the possible actions you should take. I recommend you to use that in combination with the OM guidelines, operational maintenance guidelines that your OEM is supplying you. Once again, if your water is too high in your lubricant, over a trend, once again, oil analysis, it's not one sample. Preferentially, you could look back to the oil analysis manual for the last 2-3 years and try to follow a trend in identifying root causes. The root cause is, of course, then helpful information to possibly take action during the outage. That is where oil analysis is so valuable for as part of your revision and planning of your revision. O&M guidelines as well as ASTM standards, always make sure you use the latest revisions. They have different revisions. For example, a 4378 has today a revision of 2022. VGB 416, I know it's a latest revision from 2 years ago. Make sure that you don't use a revision of a standard who is 10 years old. The same for O&M guidelines. Ask your OEM about the latest revision of your O&M manual. Then you have all the oil analysis information. You know how much contamination, maybe water is too high, and then you can, with your team, decide, do I need to flush? And the question often comes, do you really need to flush? And in that respect, I can only use a visual. I think that often a visual is more than 100 words. And in this case, I don't think anybody would like to use this bath, or at least think about if you um, are having contamination into your lubricating system, mm, just avoid any cross contamination. And this is not only talking about particulate contamination, it can be soft contaminants, it can be chemical contamination, uh, additive, which are not always compatible in the new fluids. I looked at once again what ASTM is giving as a definition of flushing with the circulation um, through the turbine which is not operating and to remove contaminants. And what is contaminant? It's not just a hard contaminant. Don't only think about dust or iron. It can be degradation or decomposition from the lubricant itself, like the Noria company is well presenting. So flushing, you've understood it, it's a catch-all term to remove system contamination during, after revision, and cleans the internals of your whole system. And there are different flushing strategies important for you when you prepare a TAR revision. Make sure you select the right flushing strategy and purification. To help you, I will quickly go through 4 of the main flushing strategies used today, the techniques, and selecting them is important to address your problem. So the first one, which is often used for large turbines, lube oil systems, and also mostly on when new units are commissioned to remove construction contamination, welding remainings. It's applying with a high velocity and with the Reynolds number above 5,000 to create this turbulent flow into your lubricating pipelines. And also then you bring it back to the reservoir and then filter it out to make sure your system is with this high velocity flush is very clean. It can also remove some corrosion product, even in some cases varnish, but it's a technique which is quite, I would say, laborious. It needs connections, special connections, pumps and skids. So, but there's a lot of specialized companies today on the market for that. Chemical flush was a technique was used in case of chemical deposits or even varnish deposits. And it's based on detergents, caustic chemicals, citric acid, degreasers. Very careful. It needs a lot of care, very well preparation. And today, the ASTM standard is not really recommending using detergents, also OEMs, because they, of course, they are efficient, as you can see on this picture, before and after. They will remove these components. Unfortunately, it needs a lot of after flushing. Just as we see from this gas turbine case study, you can see that even the smallest concentration remaining, as you can see in column number 2, you see even with the lowest remaining system cleaning after dilution, that you still have effects on your deemulsibility or water separation. And that's because you can see that the calcium content is still too high. So conclusion from this, if you use this, make sure there's no residual concentration. Needs a lot of after flushing 2-3 times. So it's time consuming, and I would say it contains quite a high risk, and it's getting less and less used, detergents. Flushing strategy that helps you to replace the detergents and dispersants is the solubility enhanced flushing by using solubility enhancers. These are modified base oils, not additives. They are pure base oils. One of the products that Fluidtech is supplying is called Decon from decontamination. And it is a product which is added in a risk-free condition to rapidly dissolve deposits in all corners in the tank, in the reservoir, on the bearings. And why is that? Because the products that have been forming deposits, they are created from depleted additives, stressed base oils. They are part of the in-service oil. So what will be the best flushing agent? It is your inherent, your original lubricating oil. It will easily dissolve again the degradation products under one condition, of course, that you increase the solubility. And that is the concept of solubility enhancement as part of flushing strategies and turnarounds. So you've understood it. It's risk-free. It's a 100% compatible solution recommended by certain oil companies today, and also very important if we think about cost saving and time savings. No need for flushing anymore. It is a very safe concept. And in general, you have to think about adding concentration between 3 and 7%, defining, depending from if you plan to change your oil or not. If it is just to flush the system, to clean in advance of your revision, before opening your turbine and avoiding these surprises. Just like Sanya was saying, often oil is forgotten and then you come to these unpleasant surprises. And so, like we say, it's very compatible with Group 1 to Group 4 base stock oils for lubricating systems. And then you get a cleaning effect, like you can see. I will show you some pictures of this cooler plate where you can see that the metal is, I would say, deposit free. I did not have the pictures before, but it is after the cleaning. This is another case study from a Siemens Energy steam turbine, where we also added 5% of solubility enhancer with heavily varnished systems 8 weeks prior to the plant outage. So 8 weeks, and you still perform the turbine or compressor under normal conditions. There's no need to stop. The solubility enhancer will increase the cleaning, the flushing, and make sure your components are free of deposits, just like you can see here. These are real field case studies with components that have no contaminants and avoid further maintenance actions. That is really what the plant wants to do, is go fast through revision and have no delays. And you can see how journal and truss bearings are free of deposits and avoid any further maintenance actions and can be used again after the oil has been brought to the system. Here another case study where you can see on the left side how the oil oil cooler plates are cleaned and like new. Also the tank, the oil reservoir, with even the oil heater, which is free of deposits, and the walls of the reservoir free of deposits and varnish. I give you another example how an overhaul can be planned successfully by looking at the oil. This was a plant scheduled for oil change in August last year to achieve, and I think that's important. The goal was to have a shorter shutdown of a plant, maximum 6 days. it's really short, and that means that that needs a lot of preparation. So as you can see, we started in February already at that plant. We looked at the full oil analysis report, decided that it needed, because of the high contamination, soluble varnish deposits and high additive depletion, it needed uh, 5% solubility enhancement treatment of this turbine. It was working for until 3 months later, with an additional oil analysis, confirmed that the system was clean. Full oil change was done with visual control. And 1 month later, another oil analysis confirmed in September that the oil was in excellent condition. So as you can see here, we went, the revision went, followed the schedule, had no abnormal delays. This is just to give you an idea about oil analysis before revision, and with very low RPVOT, so high antioxidant depletion. The ultracentrifuge 6, which is corresponding also with the high varnish potential 39, and antioxidant depletion also less than 25%, which is a condemning limit for this turbine oil. And you see again the patches with and without the solubility enhancer. And more important is here the pictures of this solar gas turbine, with pictures of the reservoir, the coolers, the pipes, and showing the effectiveness and the ease of use. Once again, there's no labor with this, just adding the fluid into this existing oil and follow up with oil analysis. That's the only effort that needs to be done by the operators, is look at the parameters here. You can see from this oil analysis report, how MPC on this fluid turbine oil is at 4, which is extremely low and in perfect oil condition. Also, I added these pictures just to show you how the main lube oil filters, before and after, you see the varnish on the outside of the filter, and after treatment with the solubility enhancer getting clean. A point I want to add for maintenance people attending this seminar is, make sure you evaluate your heaters or your coolers during this turnaround. It's so important that, as you can see on this picture from this gas compressor, how this cooler has been building up deposits, in this case varnish. These coolers, as we say, are having very cold temperatures, so the risk of agglomerating cold varnish on these coolers are quite high. So if you have a steam turbine, a gas turbine, a compressor, 10 years, 12 years lifetime, and you plan a turnaround time, please, I can only recommend you to include the treatment of that cooler and heaters. It will help you to solve a lot of problems afterwards. And why is that? Because if you would not clean this cooler, imagine if you would put that back in service with new oil. As you can see on this picture, the new oil starts to clean off partially the varnish. And you can see these pictures where some of the varnish is already dissolved. Where is that solubilized the varnish will it go? It will go to the bearings and the gearboxes in a very short time. So it will then, of course, decrease the efficiency of your flushing and cleaning. So we have spoken about the importance of preparation of oil analysis, helping you to define what kind of flushing you want to perform. Is it particulate? Is it more soluble? And then the question comes absolutely today, do I have to change my oil or not? Considering this question, there's 3 options. Either you see that your additives are heavily depleted, mostly that is a good reason to change the oil, or there's extreme high contamination into your oil system that is impossible to remove, or you have already degraded the base oil. Think about air release, who's increased. And well, in all of these cases, we can only recommend you to have a closer look at your antioxidants. Antioxidants are a vital component of your lubricant. At Fluidtech, we have organized several sessions on that. It's also our root expertise at Fluidtech with antioxidants detection. Antioxidants are the health of your lubricant, just as we show in this picture. Too low of antioxidants, which are usually not, I would say, more than 2 or 3% of your blended lubricants, besides the 95% of your base oils. But these depleted antioxidants, they play a role in defining the end of life of your lubricant. Does that mean that at 25% my oil is dead? Not necessarily. That's why you do oil analysis. We have plenty of experience at Fluidtech and set of data that has shown us that the 25% of antioxidants you still have left life in your lubricant. Your base oil characteristics can still be in excellent condition. You just have to replenish antioxidants. And I know today it is a strategy which, even in my young years as engineer, my maintenance manager was always telling me never add something into your oil which is not part of your lubricant. At that time, in the 90s, my manager was right. Today, in the 2020, it is totally different perspective. It is a safe operation, and it's certainly also a cost-effective operation. Feed and bleed operation is, we know, is expensive. Dump and flushing and recharge, as we are just discussing, is also expensive. Think about the disposal costs of your lubricant. 20,000 liter oil. It's a lot of costs today to get disposal of it. So replenishing is the lowest cost, and it's also the lowest risk. Once again, opening a system is never good, and it's always containing a risk. If you can avoid that, so you have a low risk. So the economics of a feed and bleed, we don't have to discuss that, but fresh antioxidants, they can be added. And that is what we believe is a path to fill for life. Deconeo is the product name based on the selective balanced antioxidants package into the solubility enhancer to create a very homogeneous package. It is having a 0% risk. It will create and result in significant cost savings. And of course, the sustainability aspect is, of course, very clear here and of very high value. It's an operation that can be operated on site, absolutely. It requires no outage resources. The risk, once again, I can only repeat you, we do this operation sites since 2012, and today we see the industry moving very fast in this direction of re-advertising as part of overhauls. And also, last but not least, it is a very important contribution to a carbon footprint and reduces of waste. And to show you how an AO rehydratization, antioxidant rehydratization, in the concept of how we do it at Fluidtech, it will also help you to reduce the varnish production. So think about if you have a system who's heavily depleted, it will produce degradation products. No doubt about that. Do you want to mix them with fresh antioxidants? Possibly, yes, in a safe way. When you have a solubility enhancer, as you can see here in the last column, you see how after these 18 weeks of high oxidative stress with a fresh antioxidants package and a solubility enhancer, that the oil still has an MPC or a varnish level which is less than 10, so in a very safe condition. And to make sure the risk factor is zero, we perform a qualification process following an ASTM standard to help you understand if I have my oil sample as it arrives with all the important parameters which we measure. You blend it with the antioxidants. You run a compatibility testing. You run the post-aging analysis. Then you can be sure there's no negative impact from any parameter. Think about maybe asset number or maybe your air release. And last but not least, that you have a distinct and a positive antioxidant response. This is just an example here where you can see the oil analysis data before AO addition and after AO addition. And you can see that, look at a most important ISO codes, cleanless, who's getting to a very acceptable level. The same about MPC level from 33 to 14. And beside that, you see your antioxidants moving up to a level of better than the new oil. Air release not affected, foaming and not affected. Water separability all in a safe way to make sure that how your oil is going to behave, that it will be risk-free. And risk-free means also that OEMs today, they also recommend it. It's approved. It's part of approvals of the biggest OEMs, Siemens Energy, with here a quick snap I took from post from Siemens Energy, Dr. Quick, saying that this is the future for turbine oil films. No more oil change. Think about it. No or more oil changes in a turbine oil life. It is not a dream, it's reality. It's up to you and together with your team to prepare this in a safe way. You can go and visit our website or Google just on the YouTube with one of the mesquite power plants, which was the first plant we did in 2012 with on a frame 7 gas turbine, and in 2012 the first operation. Initially, it was planned to change the oil 5-6 years later. Guess what? We are 2024. We repeated the operation in a safe way in 2022. You can see the nice trend of antioxidants in a safe way. So this oil, it's unheard because it will have a lifetime of 19 years with antioxidants fully under control, MPC. Of course, this is not just a one-stop action. No, we look at condition monitoring, we do the realization, we look at the right filtration, anti-stat filter. So there's a lot of contribution, part of this turnaround preparation. But once again, it avoids to have to change the oil. And for um, um, all the operators or attendees today, there is a way to calculate the value impact on the CO2. Once you operate such realization or lifetime extension, where you can see here how much CO2 we save in kilograms, as well money on this 10 years savings of this gas turbine, this power plant. We can help you with that, but I'm sure this is also part of your turnaround preparation to make sure that your CO2 is as extinction is low as possible. So my last few slides is before I will stop here is just another step further I want to introduce to you. So of course, we have done the whole turnaround preparation and you have a successful turnaround preparation. But think about this, if we would look at the lubricant as an asset. Today, lubricants are consumables, and I agree on that. That means that it's after 8 years, the lube oil is drained, the system is flushed and filled with new oil. But think about if you would have a lubricant that you don't have to change anymore. So never change it anymore. Uh, Capable of adding fresh antioxidants with an optimal varnish protection. Well, there's today for new projects and new builds. If you evaluate fill for life and its CO2 minimal, I would say, emission, then evaluate the possibility of using a fill for life lubricant. This is how we prepare a tar turnaround who wants to switch to an infinity turbine oil, which once again the oil sampling, the flushing and cleaning, sampling before the oil drain, the full oil drain, and then you are charged with infinity, and you have then a lubricating system which is once again formulated with antioxidants and all this, so this co-solubilizer, but have the ability to have additive replenishment. This is what has led to Fluidtech to become Solar Impulse approved and also be certified, and B Corp certified. I apologize, as part of this. And of course, this is it's a full package, Fill for Life, where also the possibility of online monitoring will be important. And just briefly introduce you to the online sensor that can also be important for turnarounds preparation. In advance, you can monitor possible fast oil degradation, um, helping you to meet the deadline of your tar. It means that on-site analysis and on-site data will help you to further increase your efficiency and also reliability. That means that if you go for a current process every 8 years oil change with often a lubricant which is cost effective, but maybe not always the highest performance. And then after 8 years, have to start again. The future is certainly for operators like you and service companies is to evaluate this. Oil management is where you look at purchasing the new oil, you're operating maintenance free, you replenish, and then you continue. And with that, you're able to go for a real fill for life project, with direct cost savings, no operational problems to varnish, and that is also important for your revisions. If you're sure that your varnish is limited, you will also have a better and an easier turnaround to perform with less consumption of lubricants, flushing oils, and of course CO2. So that is what I wanted to present to you, Sonia. Sanya, I'm ready for
Oh,
any
yes.
questions or discussions. Thank you
Oh,
so much for attending.
we are definitely ready for questions. You, I have a million questions, but I'm gonna get the questions from the audience first, and I'm gonna put it up on the screen here. We have Thanraj. Thank you for joining us, Thanraj. I know you're coming in from Singapore. He's asking when you're adding this type of decon to the products in the turbine oil enhancement, is there any long time side effects on the turbine life in terms of asset reliability issues? So I'm gonna
Uh,
leave that one to you.
you're adding the decon. I would say 3 to 6 months. Really, the more time you can give it, the better it will be. There's no long time side effects. Absolutely not. Today I cannot present that, but we have published papers on that. In fact, we've seen there's a positive long time side effect on it. Is that if you are able to more solubilize the degradation products, you will see that your antioxidants are also better protected. So. And there's certainly no reliability on the equipment because it's proven that the more of your deposits in your contaminants are in solution, the less mechanical stress you have in your equipment.
Oh yeah, for sure. And I know we have Rich joining us as well. Thank you for waking up early, Rich. We appreciate that.
Which is
Um, so he's asking about an in-situ sensor to quantify amines and phenols.
it is it is rich. Yes, it is,
Yeah.
and you will find this via Fluitech or just contact with Fluitech or Greg. Yes, it's absolutely possible today. Having said that, it is we have done correlation with laboratory testing, which is very, I would say, very good. But it's still going to be important to continue to oil analysis. But I would say, as part of critical assets, where you use, for example, Fill for Life, there it would match really well as a solution to maximize the performance of Fill for Life.
All right. I think we got that one. But
Yeah.
I'm going to my notes because I was making notes while you were talking, of course you.
Too much
So
talking.
I no, not too much talking, not too much talking at all.
Yeah.
So I yes, growing up in the industry, we've always heard that if it wasn't blended into your oil before,
Mm,
don't put anything in. It's like you're putting in a contaminant or something like that. So I'm glad you addressed that because a
mm,
lot of times that's what we've learned growing up, right? So it's like don't add anything to it. But based on the case studies and the information that you presented here, this it's still morning for me, very early in the morning. So this morning, um, I can see that when you're adding like decon or you're adding a solubility enhancer, you're not affecting the characteristics of the oil. So you're not affecting the air release. You're not affecting any of the viscosity changes.
mm.
So some of the main things that are critical for turbines.
Yeah.
So my main question is when we're planning for this shutdown, when we're planning for this turnaround, how do you determine when you start adding decon or when you start adding a solubility enhancer
Mm,
to your equipment? How much in advance do you need to do that? Because I know turnaround plannings, they can start as much as a year in advance,
mm.
right?
Yeah.
Because, just like you said, getting the budgets aligned, getting
Yeah.
everything else in order.
Yes.
So, what is the best time to start evaluating your system on whether
Uh,
you need to
mm.
do
Well, yeah.
solubility enhancer, flushing, any of those things? I know you kind of covered this in your presentation, but I
No,
still
it,
like to
it
hear you
it's
talk.
it's a very valid question, Sanya, and it's a question that very often I approach when I'm in these teams, when I'm consulted as part of
Mhm.
turnarounds, and then I always tell them, "Have you made up your timing? Have you had an idea about?" To answer that question, it depends really also from other signals they have received in the years or the months before. Just think
Right.
about they may have had issues with sticking valves.
Mhm.
They may have had issues with bearing temperatures increase. They may have had vibration issues. All of this I try to understand when I'm part of that
Mm.
team. And then if I see, for example, they've had a bearing temperature increases and due to that, then I tell them that they should do it really like already maybe 6 to 8 months in advance because it can be uh, unfortunately, it's called hot varnish.
Mhm.
This hot varnish can be absolutely very, very tenacious,
Yes.
very harsh, um, and so. But if, for example, so it's never going to be too late. It's too early to add. I'm sorry. It's never
Okay.
going to be. It could be only too late. That was
Uh,
my point.
it's
Valves, for example, I see that now more and more on the a newer generation of steam turbines and then they see that their valves are suffering also
mm,
there because the circulation of the oil through the feed lines to the valves is not as much as on the lubricating system. So give it more time.
mhm.
And so then I would say again 5 6 months if you have it added.
Yes.
But on the opposite, I will tell you, Sanya, it's if they don't plan this and and I see still case studies where 1 month before the oil or before the turnaround, that they start asking these questions,
Yes.
then it becomes very difficult.
Mm-hmm. Yeah, because I'm just, and this is just from, being in the industry, working with some of these people in industry.
Yeah, yeah.
They don't, and they forget about the oil when they're doing the turnaround, and then it's just that quick moment adds up, like, oh wait, do we need to do this? And
Mm.
I love the fact that you talked about the oil coolers, because they are also a
Oh,
forgotten part of the components.
big
Like,
time, big
yes,
time. Yeah,
definitely.
yeah,
Because a lot of times that's where the oil has to pass. Like, you definitely want those clean. And that's,
yeah.
again, another area that is overlooked when we're planning for turnarounds, something that we
Mm.
definitely need to take a greater look at. So I'm going to ask another question again, right?
Yeah, just to
Yes.
interrupt you, to come back on
Uh-huh.
Sanya, I will ask you,
Mhm.
I will let you ask the question, but on these coolers,
Mhm.
important is that very often they have two coolers. They have mostly one in operation, one in standby.
Ah,
So they have the ability then to during those outage to say, okay, I'm gonna put the one who's in standby, then use that for operation and
yeah.
give it the time, because then the cooler bundle has to be removed. Of course, it's a quite um, elaborate operation. They need to remove the bundle, bring it outside the plant for chemical treatment, because it's quite heavy, this treatment, then flush, clean it, bring it back. That needs preparation, but as they have two of them, it can be done already in advance of the
Okay.
revision. So now
Okay.
I'll ask to your question.
Yes.
Listen to your
Yes.
question.
I got a bit distracted because Tanraj is coming and he's asking me a very great question here. So I'm gonna give his question preference. He gets
Yeah,
priority this morning.
yeah.
So Tanraj, I don't know if it will fit on the screen because it's a bit long. So he's asking in a nutshell if phenol-based product is stronger than amine-based product in a nutshell. Like, I'm gonna condense the entire thing. So I'm gonna give you some time to read that a little bit.
Oh, yeah, but I think the answer I want to give here is that um, Tanraj is antioxidants package with the experience we have, and personally I have it. Antioxidant system should be balanced. It's important. They are balanced systems between primary antioxidants or secondary antioxidants. Um, that's clear. So we will not focus on one type of antioxidants, not even deconio. We will not say only phenols or only
Right.
amines. No, no. When we developed deconio, we have looked at, like I say, a lot of sets of data we have of FluidTech, how antioxidants deplete. Um, and so that means that the package we have developed is a very well balanced antioxidants package, also not too much, because we know that there have been one of the root causes today or in the past, and not today any. I think it's improved, but in the past there were like additive packages in lubricants which were extremely high to
Mm,
achieve a high RPVT
right.
value, because that was the
Yeah.
benchmark, which was unfortunately not really always a good solution, but it should be balanced. And
Hmm.
so what we do with Deconeo, the advantage is it is solubilized in this solubility enhancer. That gives us an advantage because we can mix very different type of antioxidants, well balanced, to work not only at low temperatures, think about steam turbines, hydraulic systems, but also work at high temperatures. Which we have proven with our TOPP testing. Greg Livingstone and Sanya have published that in the book, Understanding the Cholesterol. There's a whole article. Solar has tested that with how you can see that amines, phenols, how they behave. But to answer your question again, Tanaraj, is that we will not focus on not only on one type.
Hmm.
And then it should be well balanced into a base oil who has a capability of
Right.
keeping the degradation products, if it is an amino or phenol or secondary, nicely in solution. that is critical.
Hmm. And just the synergy between the antioxidants, because you don't just always want to have one antioxidant in there. You want to
No,
have that balance, you want to have that synergy. So,
yeah,
great answer to that one. So, I'm
yeah.
going back to my million questions because I have that written down here. How how much in advance? And we talked about, planning the turnarounds and doing these things 6 months in advance. Now, with oil analysis, I always like to say having more data is better so that you can establish a trend. So if somebody is deciding that in the next 2 years they're going to do a turnaround,
Hmm.
should they start their oil analysis from now? And
Yes, yes,
what
yeah,
sort of
yeah,
tests should they be doing
mm, yeah, yeah,
going in pre-planning before
yeah.
that turnaround, 2 years in advance, let's just say.
No, no, that's. But in any case, Sanya, it's a very good question. In any case, if they have already reliable equipment and with a reliability program, they should follow the OEM guidelines, which is telling them that they should do regular oil analysis. For example, a steam turbine every
Mm-hmm.
6 months, a gas turbine every 3 months, quarterly, critical equipment even faster. Um,
Mm-hmm.
so they should follow already that guidelines because. It will help them to establish a trend. If
Yep.
they use a right laboratory, they will probably also have from the trend have good diagnostics. If not,
Mm-hmm.
they can work with the oil supplier or with companies like Fluitech to help them do the diagnostics. And then, based on this data, like 2, 3 years in advance of their revision, they can then say, okay, what are the expectations? It looks like we're having foaming issues already. My antioxidants are getting low.
Mm-hmm.
Probably we'll have to change that oil.
Yes.
Um, but in addition to that, what is so refreshing about new oil analysis techniques like MPC ruler
Mm-hmm.
is that you can take already much earlier corrective actions. Like you published, I read your paper on antioxidants that
Thank
was
you.
recently, which was very good. I love to read that paper. I enjoyed it so much, and I mean it's so corrective. It's like a human body. When you're not
Mm-hmm.
going to wait until you're exhausted to go
No.
to the you're gonna when you feel I don't sleep well or I don't work well
Mm-hmm.
or I don't have good sports time, then it's the same with the lubricant. You're gonna add then maybe and that's the strategy that we think is that you can extend the lifetime of the
Mm-hmm.
lubricant and the revision possibly, because if you have a longer lifetime of the lubricant you can extend the revision time, because today, let's be honest, Tanya,
Mm.
um, revisions are often happening.
Yes.
I would like to make a study, but unfortunately we don't have the data. But just to find out how much revisions are caused because oil lifetime is too short.
Yes. Yes.
And,
Definitely.
and if
Like.
you could extend that, that is also turnaround preparation. So your
Mm-hmm.
question is very valid. Start with it enough in time, but in any case, already put efforts in your own analysis program, like your OEM is telling you, or your
Right.
ASTM, or DIN, or as standards, oil analysis standards.
Yeah. Because like quite often, and we hear it a lot within the industry, they start saying they have no budget for oil analysis. But when you look at the cost involved of
Mm.
your turbine going down or unplanned downtime or anything like that, that's a lot more than what your oil analysis is going to cost you. So do your
Oh
oil
yeah,
analysis.
oh yeah.
Definitely do your oil
Oh.
analysis.
And that's the ongoing battle always.
Hmm.
But it's also the same about the other mechanical components in a turnaround. They also have to make estimations
Hmm.
and think about changing the bearings or maybe the gearbox or
Yes.
the rotor, no the gear bull gear or some components of the compressor. It's the same, but I think with lubricants today, there's now so much tools.
Mm.
It would be, I would say, so sad to not
Yes.
look at and use those tools which are available. Huh?
And there's one other thing that you mentioned. I think it's just important for people listening in. Oil analysis should not be done just before the turnaround only. It should be done after as well because you want
Yeah,
to monitor the health of your oil
yeah,
going forward. I mean,
mm,
it's just like the human body, just like you said, you
yeah.
know, monitoring is part of
Mm,
it. It's just getting all of that sorted, being able
yeah.
to know what's going on.
Yeah, no, that's very valid because we have seen case studies where
Mhm.
outside companies they are coming to do some of the flushing and the cleaning, and then they use detergents or
Mhm.
dispersants which are not always known by the plant, and then 6 months later, they
No
see
problem.
foaming, air release destructed, and then they say, "Yeah, but can we go back to the oil sample? Oh, we don't have it."
Mm-hmm.
So yeah, excellent point,
Yeah.
Sonia. Is that after 1 month latest, and I would say even shorter. I even say
Mm-hmm.
72 hours after
Right.
circulation, the new flushing oil or the new oil, get a reference sample, even if you have the sample just there as a
Yeah.
reference. And then after, if problems occurs, you can always fall back on that one reference sample and say,
Yep.
look, oh, there was so much calcium. Oh, look, there was like already an air release of 9 minutes. And
Mm-hmm.
of course, it's too late, but still you have that reference sample. So yeah,
Yes.
excellent points. Yeah.
Yeah, because sometimes I know, especially with these turnarounds, um, the blame game happens quite a bit when things
Oh,
go wrong. So
okay.
having that reference baseline sample, that saves
Yeah.
a lot.
No,
Just
good.
take
Yeah.
the extra time and get it done. So I know we are at our time limits.
Yes.
Unfortunately, I could
Okay.
spend my
Yeah.
entire day with you, yo, but
No, no,
I'm not allowed to.
no.
So I'm gonna let you get back to your day. Thank you so
Okay.
much for sharing all of your knowledge with us.
Yeah.
And for everybody who either woke up early, stayed up late, or
Yeah.
were in their time zones, thank you
Yeah.
so much for joining us this
Thank you so
morning.
much.
And have a great rest of your day or night
Uh,
or remainder of the month. I'll say that. Yeah.
Thank you, Sanya.
Thank
Thank you so
you.
much. It was a pleasure being with you,
Always.
and say hi to everybody on this seminar. All the best. Thank you so much.
Bye.
Bye bye. Thank you. Bye, Sanya. Speak to you soon.